is, maybe, Robert,
Well, we'll wait till he explains.
Yeah, sure. I can give them a very brief introduction.
okay, good, okay. Robert, come on around here, Robert, give you sign in here. I'll pick up a cookie. You have two, maybe, that's enough for today.
Everybody say hi.
Hi.
This video will go to our colleagues who are not here.
We're actually, there's underground movement, one of these revolutions going on. I like to be associated with
Actually, it is.
Yeah, sure.
Thank you. Because we have students who are not here. They're distant work, so we want to send them. It's not going to be on.
Yeah, you can take pictures, the videos.
Yeah, it's not going to be public. Thank you. And you are? Your name is?
Robert. Robert.
This is Robert. I'm Daniela Simmons.
Hi.
I'm one of the
Welcome to
instructors
ZOE.
for the class.
This is the mechanical room.
This is the mechanical room.
Yes,
Let me.
all the heat pump, the reading floor is. You see the manifold have 9 loops of water that go underground. Yes, and circulate around the building to carry out the heat. Yeah.
Very interesting. Sure. And here everyone is signing. I'll sign later. Dr. Inman. And this is our speaker, Susan Paris. Susan, say hi.
Hi.
Hey. So
I'm happy to be here
our
today.
colleagues who are
Very
not with
interested in
us,
this.
they will know who you are. Okay. Yes, we try to accommodate people with different schedules,
Thank you.
living in different places.
I can see Robert again. The cookies in the water.
And cookies.
They have moved that far, right?
This is so nice.
And Robert is a graduate student in his master's or doctorate or master's degree
Yeah.
in mechanical and energy
Energy engineer.
engineering. They have something like 47 faculty in that department.
Yeah, almost.
Almost. They have some postdocs.
Doctor, yes.
Rambo,
And Dr. Moon. Moon. The Korean guy.
Korean guy is
Yeah.
a postdoc.
Yeah, postdoc.
Okay. And this department has grown very, very rapidly. Dr. Tao, for example, did a ZeroNet energy in 2008 in Beijing for the Olympics. The Chinese government asked their former colleague from Shanghai, who has been in Florida, and he went to Michigan some, and to come back and build this house. And I think that's quite interesting that they would ask somebody who left the country instead of asking some local person in China to go build that house back in Beijing. That means that he's respected. He has an MOU with a real estate firm in China. I don't know if I got this right. Years ago, I heard to build 100 ZeroNet energy villages, or 100 sustainable communities throughout China. And when they do that, they don't build little 100 houses. It's 10,000 or whatever. For example, Saudi Arabia talked to colleagues of ours to build 10,000 ZeroNet energy houses in Saudi Arabia recently. For example, that's the kind of stuff that's going on around the world now. And so this department is working with us. We put a proposal in for retrofitting houses like Denton, or a city like Denton, all the apartment complexes, all the malls, all the way. With the bank proposal, we put that in recently as a research proposal, and so there's a lot of excitement. And but I'll let Robert now explain
a question before
Yes, sir.
that. When you refer to the Arabian or the Saudi Arabian developments and the ones in China, does that mean it's this technology that we're about to
Parts of
see
it.
here?
Parts of it.
Or there are variations of this technology?
Okay, my name is Robert. Welcome to ZOE. The full name is Net Zero Energy Building. What does it mean by net zero? This building is this part is the working area, that part is the living area. So it's a combination of a residential and commercial building. So this building will consume a lot of energy because we have all the lighting, we have computer running, and also the HVAC part. So, but we also have the energy generation. We have the solar panels right here on the roof, 24 pieces, 5.6 kilowatts. And also we have the wind turbine, it's 3.5 kilowatts. So we are trying to make the energy consumption and energy generation balance. It means that on an annual basis, we don't consume energy from the grid. Okay, this building is connected to the grid because in the night hours, we don't have the energy generation, maybe very, very small because we don't have the sensor. So we use the energy from the grid. But in the daytime, when we have more energy generated, more energy than consumed, we will export the energy to the grid. So on an annual basis, we are trying to make it net zero. We actually have a reading flow system. You can oh, you're trying to feel it. We have two HVAC parts. The water-to-water system, it means reading the flow, and also the water-to-air. You can see that the big tube, it will distribute the air to the room. So this is the two main HVAC parts. We have 6 valves.
Everybody know what HVAC means?
It means air conditioning. Air conditioning, ventilation. Yes. Yes. We have 6 valves over there. 6 valves. Each valve is like 250 feet underground. So the water from underground, in the summertime, it's very cold underground. In wintertime, it's very warm. So that water will come into this building, go to this manifold, and then into 9 loops. This 9 loop will circulate into the building. So the water in the loop will distribute, like give the heat or carry out the heat. So this is like the air conditioning system.
Everybody understand those wells, because I think that's the concept for people. They don't quite understand that. He says that how many wells?
6.
6 wells. Okay.
Yes.
What that means is the pipe is going down 250 feet down
Yes.
below this place in the back. It's not under. Is it under the building or over here somewhere?
Over there.
Over there. Okay. Over there.
Effectively.
So it goes down, and by circulating, I think at 250 degrees. 250 feet below. The Earth is 62 degrees. I think roughly. Is that fair?
Yes, roughly.
Roughly that. So if you take water that's cold water or warm water, you're doing heat transfer. And we have a whole preschool program over here on 288 that's all has 100 wells, 10 foot each, to do that system. But that geothermal is the big name for that, and it's somewhat new as a concept. You can't quite do it for your individual house; it's too expensive.
Yes.
But for a place like this, you can.
Yeah, because this is for research. This building cost about $1 million. That's a lot of money.
Now, do you have an active water heat system?
Yes.
So that's what's
Yeah.
connected up to
Yes.
the radiant
Yes.
core system? I
Yes.
didn't know if you had the dual tank or.
Yes,
what.
it's on the second floor.
Uh-huh.
The water from the wells will go to this pipe, and then it will divide into 3 different pipes. One pipe is for reading the flow system, one pipe is for the water-to-air system, and one pipe for the solar water system. The solar water means it uses the sun side, the solar thermal collector, and to warm the water for your shower, and anything. Yeah. We also have a tank. Yeah.
But it's freeze proof.
It's all on the second floor. You can go upstairs later. Another point is that this building. So while we design the roof like this angle, and if you go outside, you can see that there is an angle that this roof goes down. Yeah. Because when Texas we have some water, it's like pouring a lot of water. So this water will collect into the roof and then go to that water tank. You can see later, we have a water tank over there, and we collect the real water.
For the system, the rainwater.
Yes. And the water will go to the filter system. We have the UV filter, the carbon filter, and then we can use it for the toilet, or irrigation. So this will save a lot of the water.
Except when the drought's on, like my cousins down in Austin, and they kept on having
It's hard to get enough water, that's for sure.
Yeah. It's a wonderful thing. So, the system is on right now for the radiant floor where y'all are active in here, is that right, or is it on right now?
It is on right now.
Okay.
Yeah. Because it depends on the room temperature. Yes. I'd like to mention that this lights, we have the 16, this LED lights, you consume very little energy. So why we design like 16 small lights here? Because sometimes, because you are working here, you don't have to open all the lights. You have to just open this one. So this will save a lot of energy.
Can you turn one on so we can see how bright it is?
Yeah. It needs a while to start. Right now it's just started. It may take about 1 minute to.
And is there not much heat generation from these, as far as that goes? Or
Compared with the conventional ones, it can generate very nice.
I think it's a lot less.
Most of the energy comes like 20 watts. It's very nice. And also this window is our double pane, and we call it the low emission. Means that we don't have the sunlight coming in, but we do have the heat coming in. Yeah. Because we have a lot of the windows. If you have all the heat coming in, then we will have a lot of the heat load. So you use more energy for the HVAC part. You can feel that. No heat, yeah. But the sunlight will come in. Yeah. And also, you can see that we have many steel frames. Actually, this building is, we have the walls and the frames. This wall is made of the SIP panel. It's like a composite material. And one of the ideas is that the tower want to, you can remove all the walls. Then we will have the frame. And then he can put some new wall. So by this means we can test what is the material, what is the thermal performance for different kind of material. Maybe 10 years later we can have a new material. Okay, then we remove this wall and put a new material here. Yeah, because we have a frame, the frame will be here all the time.
Is the R value on this pretty good? For the, you said it was strong?
It should be very good. We have not measured the R value yet. Yeah, I think it should be very good. It then composes different layers. Yeah. We can come to this living area. Yeah. Also, this part is actually a solar chimney. You can see that we have a fan over there that is in above. This, yeah. Actually, this part should be painted to black.
Okay.
Yeah, but right now we have not changed the color yet.
Why?
The black color, in the winter time, the sunset it will collect more heat.
Oh.
Yeah.
So even the color counts. What kind of color you put in? Okay.
Yeah, the color, because color matters. The heat will collect the most heat. We have the windows coming, and then we have a fan, the ventilation here. So it's like we call it a solar chimney.
So it's for heat, it's not for really for burning wood.
No, it's like a chimney. This small window is for the ventilation. You can see that because like in the winter times we have the cold air and the warm air. Because cold air will be in this layer, yeah, much lower. So when we have the ventilation, it will like blow the cool air out. And then the heat that collected in the small chimney will distribute it in this building. Yeah, so we call it like the ventilation. The floor is made of bamboo. It's, because we mean green in the Western North Texas. Yeah, this is made of aluminum.
Is the bamboo sturdier than regular wood?
I think it's maybe more clean compared with like the concrete. Yeah.
Faster to regrow than a tree.
A little bit more sustainable.
Sustainable.
Yes, yes. Yeah, if you look at that, we have so many copper cap here. It's actually the sensors. We have a Snyder, he designed a system, he put like more than 100 sensors in this building. Then we can know like what is the temperature in the floor here or different parts. And all these sensors, they will send a signal to the computer, and then we can know, okay, at which point, at what temperature, what about the ventilation, what about the flow rate. Okay. This is very useful for our experiment, doing the research.
What's this?
Oh, this is background lights.
What's that?
Background, it's just a lighting system.
Oh.
Yeah.
So, and the shading?
I can turn this on. See?
It's uplighting, is that it?
Yeah.
Isn't it funny? We
And
can
it's
figure out.
automated?
No,
Or is it their manual?
It's manual.
Oh,
Manual.
okay.
So you get a bump in all your graphs with all these warm bodies exhaling.
Well, that's part of it as well, Robert will tell you. That's why this space is here. So somebody actually could stay here week after week and they could, part of what they want to do is the lived environment. In other words, architects build these things, but people use them differently. And so one person might live here and use up more electricity, another person uses less. The discussion we've had recently, is all education for me, is that you get a sample of 1,000 or 2,000 or 10,000 or whatever people living in a space, like then you could sort of do the distribution, right? Cut off the ends and sort of come up with a median indicator as to how that building performs with a diverse population in it, like a distribution, and so.
Yes.
But you have to have big numbers, and so the debate we had in the last couple of months was, where do we get those data sets that will will allow us to do that? That collected that data longitudinally, cross-sectionally over time. That's the hard part. And,
Yes.
This house, they have a little bit of that with respect to this living space.
Because we can use the most advanced technology, the most efficient, but usually the human behavior will be a very important role. We call it net zero, but if you turn everything on all the time, it's not a net zero. But if you turn it off, that's totally net zero. You don't consume anything, but there's no comfort. So by changing the human behavior, like I do some simulation by changing the set point, by changing the schedule, by changing what is the lighting level, the equipment level, you can have different results. This is actually more important, like you change the equipment, HVAC part. Yeah, it saves more energy.
Where's the cooking stove?
Oh, we don't have that.
Oh, I saw the microwave, that's why I said that.
That's the only thing we have.
These are college kids.
Asking because of the building, if it's intended to be net zero, somebody's got to cook eventually.
Yeah. I think someday we will have that, but not right now.
Right now, it's
Some of the stuff over here on the wall, some of that I think
glass.
Recycled.
Yes. Because Dr. said actually on the wall, it's actually some not useful material, maybe from somewhere else. Yeah, so it don't cost any money. I don't know where he get it from. This part is the restroom. We have a sensor. You go in, it will automatically turn on. And when you leave, like after 5 minutes, it will turn off.
It's manufactured.
Commercial dishwasher. Yeah, rainwater for the toilet.
So the water harvesting on the back, we'll go around the back, is used in here for the bathroom
Yeah.
function. And filtering, can you drink the water? Is it filtered?
Yeah, it is portable. It is
Right, portable, so
Yeah.
the water you can drink there, as well as the toilets. And,
Yeah.
So it started. So, and if you go to a website called conceptrenewable.com, okay, you go on that website in Dallas here, and a company has set up a monitoring system for that windmill out on the back here, as well as the one behind the ESAT building. And about 5 to 10 or so schools in Dallas and St. Louis are on that website being monitored every day as to the energy production and the energy consumption. And I met with that fellow Thursday, and my dream is to take him to Guadalajara with me and do that deal with Subre and Cum College Union, Mexico. These are K through 12 schools, and we put the wind and solar or whatever combination and have them on that website, just like this windmill came from them, and the one which is a kind of one of these windmills that goes this way, and there's a solar panel. If you go behind ESAT building, you know, the educational environmental building, and so that's a neat, you know, kind of for education of children and parents and everybody about how these things work and how much production is, you know. So,
That's a wonderful thought. At Subire,
Yeah.
the second school.
yeah, right. That's right.
That they have, don't they have enough land out there that they could do a whole
Yeah.
little community?
Oh, yeah, well, yeah, we can move in the whole community, but first I want to get the school, you know,
Oh,
kind
sure.
of running up first.
Yeah, I can show you the website.
Good.
Yeah, for energy
Oh, you know, okay.
consumption generation. I know that one. Yeah.
Okay, good. Okay.
I wonder if this is it.
Yeah, this is we call it the energy meter. It actually have the sensors attached to the meter and send a signal to this website. You can say we have two lines. We have the green line here and also the red line. Red line means energy consumption, and green line means energy generation. This period is net hours. You can say that we have no energy generation because the wind speed is very low, we don't have the wind turbine generation, because we don't have the sensor. So in the net hours, we consume a lot of energy. This is the total energy we consume a lot of. And then in the daytime, we have the energy generation goes up right here. So at this point, generation is much higher than the consumption. So we have the energy export to the grid. You can see this is real time, and this time is very close. Because today is not a very good day. It's like a little cloudy. But usually, I can show you yesterday's data. Yeah, see yesterday, at this period, we are export energy, we use the energy. So we are trying to get net zero, but still we have some difficulty.
Well, what you don't have on there is the solar, right?
Solar is also here.
It is. Oh,
It is here, yeah. This is total energy consumption.
Okay.
Because Texas is not a very good place for the wind turbine. The wind speed is not very stable, and sometimes on, sometimes off. So our main source is still the solar panels. I can say that 90% comes from the solar panels. Maybe only 10% from the wind turbine.
I may have misunderstood. You're able to measure how much power you're getting from wind and how much power you're getting
Yes.
from solar separately?
Yeah, we can make a separate. We have another website that I can show here.
Oh, well, that's okay.
It doesn't matter. I can show you.
So you can measure to see where you're getting more energy than the other.
Exactly.
Because all of this is research.
Yes.
And then they're measuring how much they're
Yeah.
using versus how much they're generating too, which is.
Say 24 pieces. We can know which piece will generate more energy independently, and also the total energy.
And you said how many sensors you have in this building?
We have about 160.
So for every space in this building, you know how much energy is being expended.
Not actually, but we can know. This is an energy meter. For example, this meter will measure the plug load. This meter will measure the lighting, and this will measure the HVAC curve. So we can know like energy consumption for different components, but we still have some difficulties learning which part. Yeah. But we divide into different components: lighting equipment, the HVAC, and the miscellaneous. Yeah. I can show you some data I collected yesterday. You can know that the still HVAC is the main energy consumption. Yeah, you can see that this is the equipment, means the plug load. This is the lighting. This is HVAC. So HVAC is almost every time it is.
That's both heating and air conditioning.
Yes, yes. And also the ventilation, everything. HVAC means air conditioning and the ventilation, refrigeration, everything. Yes.
And that's for how many people?
Yesterday we have a meeting. It's like 6 people. Yeah. So if you want to reduce energy consumption in your home, the main source is to control the HVAC. Change the set point. Yeah, that will.
At this point of the building, and the research, you're on the grid.
Yes.
You're generating energy, but you're still using some of the grid.
Correct.
Do you know if you've gotten to the point that you've generated enough to put back into the grid?
Yes, it's on the e-gate here. When the green line is above the red line.
Okay.
Yeah. We export the green.
Yeah, I didn't understand that at all.
Yeah.
Do you have like a moisture removal system